Students, we will today start with more examples to understand the Nyquist criterion and a Nyquist plot, Nyquist contour. So the two Greek symbols used in Nyquist criteria is one is gamma. So you correct it like almost like a T, that is gamma, capital letter of gamma. Then another symbol used is epsilon. So try to understand that. So now we are going to the next problem. So we will try to understand, and what we can do is, yes, we will yes, here in this problem, if there is a pole on the imaginary axis, what happened? So here, as you can see here, yes, draw the Nyquist plot, and this is example 8.3. Draw the Nyquist plot and assess the stability of the closed loop system whose open loop transfer function is given by g of s into h of s k divided by s into 2s plus 1. Now when you are analyzing this open loop transfer functions, it is an open loop transfer functions. When you are observing it, there is no 0. There is not s plus term on the numerator, so there is no 0. There are two poles. One is at s is equal to 0. That means it is in origin, or it is in the imaginary axis. It is in the origin as well as it is in the imaginary. It is in the origin. Don't confuse it. Then another is 2s plus 1 is equal to 0. That means s is equal to minus half. So 2s plus minus 1, plus 1 is s is. Now, the given open loop system has a pole at the origin. The Nyquist contour must therefore be intended to bypass the origin like this. Like this. Nyquist contour should be bypassed. There is a pole at the origin, so Nyquist contour must be bypassed and remaining on straight line till here. Here also it is a straight line, and C2 is same as above. So Nyquist contour, as last class I told that it is drawn on S plane. Okay. So now here, when you are observing it, the problem is we are converting into an open loop transfer function in sinusoidal form. So we will get a g j omega. S is replaced by j omega, h j omega. So k divided by j omega into 2 j omega plus 1. So here, what is the problem is, in previous problem, in this problem, that is 8.2, what happened is we are getting s plus 1 and s minus 1. We converted into frequency form, sinusoidal form, that is j omega plus 1 into j omega minus 1. Then, if you are multiplying this denominator term, you are getting a 1 plus omega square. It is a real term, not an imaginary term. So automatically it came as an imaginary term. Numerator, you will get it as 4 plus j omega. So you can get a pure real term and an imaginary term, you will get it. So this is our requirement. So when you are coming to this expressions, you are having k divided by j omega into 2j omega plus 1. So here it is, from this we won't get a pure a real term at the denominator. So what we can do is, the normal practice is, the complex conjugate of the denominator term, this term, second term, that you have to multiply in numerator and denominator. So this form you should convert into standard form as 1 plus 2j omega. So j omega as it is, then 1 plus 2 omega, then complex conjugate of this form, that is 1 minus j2j omega. Then this same term you have to multiply in the numerator also. Now, as you can see here, when you are multiplying it, you are getting 1 k minus k into 1 minus 2j omega. When you are multiplying these two terms, it will become 1 plus that is a plus b into a minus b, that is a square minus b square. So here minus j square 4 omega square, j square is again minus 1, so it will become 1 plus 4 omega square and j omega. So now here k minus 2j, so what happened is here yes, it is equal to when you are looking into this will become so when you are looking into this, you can see that it become numerator become k, okay, k minus j k 2 omega. Okay, so here this numerator become k minus k will be multiplied, so j k 2 omega divided by this term. Yes, so 1 minute. So I am getting k into 1 minus j k into 1 minus j k into 1 minus j 2 omega divided by j omega into 1 plus 4 omega square. So this we can write it as k divided by k, okay, k and j, yeah, k divided by j omega into 1 plus 4 omega square. Okay, then k will be multiplied by, then j will be cancelled, omega will cancel, so you will get a minus 2k. So here when you are dividing this omega will be cancelled, j will cancel, so this 2 minus 2k divided by 1 plus 4 omega square. So I am getting like that. Okay, now this j can be taken up. So when you are doing like that, what you are getting is here minus 2k into 1 plus 4 omega square. If you are taking the j above, if you are taking this j above, so if you are taking the j above, so this will become, yeah, minus j. Okay, so minus kj. So you should try to understand this, all of you. Okay, so here, as you can see here, k into 1 minus j 2 omega divided by j omega into 1 plus 4 omega square become, okay, this is anyway there is a minus term is there. J will be cancelled, omega will be cancelled, 2k divided by 1 plus omega square. This is the real term minus. And second term is k divided by j omega into 1 plus 4 omega square. That j, if you are taking above, it will become minus j, k divided by omega into 1 plus 4 omega square. So you are getting in the normal form, completely a real term and another imaginary term. So now you have to apply. So first you have to see the contour C1. First you have to apply. You can start from here for a minus j infinity minus j0 minus j0 plus then plus j infinity. So you can start like that. Okay, you can start like that. You can start from minus infinity, then 0 minus omega minus infinity, then 0 minus, then 0 plus, then infinity. Now when at omega is equal to, this is for C1 of the Nyquist contour, what will be it, how can it can be mapped into QS plane that we are observing. That's points in the Nyquist plot. QS plane is nothing but the Nyquist plot. There we are obtaining the points. Okay, so at omega is equal to minus infinity. At omega is equal to minus infinity, you have to substitute omega infinity here. So you know that infinity, so this will become total and infinity. Okay, so some term divided by infinity is definitely 0. So minus term is as minus 0. Then second term, if you are putting apply, minus j is the k divided by infinity. Okay, so here we are applying minus infinity. Okay, so here minus infinity square become plus infinity square. But here minus infinity, if you are putting here minus will become plus, and some term with this will become a 4 minus infinity square. So this will totally become, you can say, infinity square. And here one more minus infinity is that minus and minus together will become plus. Some term with infinity it become 0. So it is minus 0 plus j 0. Now at omega is equal to 0 minus. This is very important. Okay, that sign is very important. Omega is equal to 0 minus. What happened? So now when you are substituting omega is equal to 0 minus omega square, you know that 0 minus will be square means minus will be cancelled. So it is 2k divided by, this will become 0. 2k divided by 0. So it is 0. So 1 plus 0 will get the denominator. So you will get a minus 2k. Then here 0 minus is there. And that minus will go and this minus. So it will become plus here. And some term with divided by 0. And this will become 0. But 1 plus 0, 1. But this is, there is omega, that is 0, minus 0. So minus is taken here and it becomes plus. Some term divided by 0 is infinity. Now when it becomes 0 plus, what happened? When it is 0 plus, here it is same as minus 2k only, because 0 plus square also 0, 1 plus 0, 1, minus 2k by 0, minus 2k. What about here? Here it become k divided by 0 plus, okay, plus sine, and this 1 plus 4 omega square, that is 0 square, so this become 1 plus 0, so 1. This also plus, so here this sign is minus k divided by infinity, so it become j infinity. And when it is become at omega is equal to plus infinity, what happened is plus infinity means this will become 1 plus 4 omega square, that is infinity only. 2k by infinity, it is 0 only, minus 0. And here minus sign is there, minus j, k, 1 plus 4 omega square, that is infinity square only. But here also positive, so sign may not be changing, so here minus j0. So you got 4 points. So we get 4 points, draw the approximate Nyquist plot. So what you can do is we can start doing approximate plot. When omega is equal to minus infinity, you are getting minus 0 plus j0. So you are getting at omega is equal to infinity, you are getting minus 0 plus j0 above here. Minus 0 means left of this imaginary axis. Okay, real term is minus 0. So it is left of this, plus means above, just above. So a point here from the origin on the second quadrant, you can means it is 0 only, but that will come on the second quadrant. The start 0 position only. So minus 0 plus j0. Then next we go to omega is equal to 0 minus or minus 0. 0 minus. When omega is equal to 0 minus, you are getting minus 2k plus j infinity. So it is an imaginary term minus 2k. So suppose here you take suppose here it is minus 2k and plus j infinity is here, so you are getting a point here. So you have to draw a line from here. Okay, now then when omega is equal to, next is after 0, omega is equal to 0 plus, what happened is it is minus 2k minus j omega. So you are getting a minus 2k minus j infinity, so you are getting a point here. Yes, and when omega is equal to plus infinity, you are getting a point minus 0 minus j0. So minus 0, that means minus 0, minus 0 means this side, minus j0 means to this, it will come in the third quadrant and it is 0. So you are getting a point like this. So you are getting 1 point here just in the second quadrant, then 1 point here, then another point continuation from here, next point is here and next point is here. Now we need to draw it. So we need to, what happened to the C1 as well as next we need to draw the C2. We have to calculate the C2 how it is, as well as here because of poles at the origin we have to calculate the epsilon E j theta also. Now for that so here for that our expressions, yes, our expression is k into s plus 2s plus 1. For that, what you need to do this? So infinite is a small semicircular indent around the pole at the origin of 8221A, that is here, this one. So origin of figure 8221 is represented by s is equal to, wherever s you have to substitute epsilon e to the power of j theta. Here wherever s you have to substitute epsilon into e to the power of j and epsilon tending to 0. And here another important thing is theta varying from minus pi by 2 degree through 0 to plus pi by 2. This is also very important. Minus 90 by pi by 2 degree to 0, then to plus pi by 2. So minus pi by 2. It is like the angle. You can see how this is. It is the arrow is from here. Okay, minus pi by 2 to 0, then plus pi by 2. The direction is like this because you know that it is starting from here. You see that the C1 is starting from here. If there is a pole, the direction should be in this way, then like this, then like this, then like this, then like this. So the angle is from, this is 0 degree. If you are coming like this, this is minus 90 degree. If you are going like this, this is plus 90. So it will be minus 90, 0, plus 90. Then what about this C2 arc? C2 arc is plus 90 starting from here. So plus 90, 0, minus 90. So that difference you should understand. Okay. Very okay. Now here E epsilon tending to 0. So we will substitute this in our expression and we will see that. So I have written that. So here limit epsilon tending to 0, k divided by epsilon e. This is s is epsilon e to the power of j theta, then 2s plus 1. So 2 epsilon e to the power of j theta plus 1. So when epsilon tending to 0, this will become 0. So 1 plus 0, 1. So this will be cancelled. So you will get k limit epsilon tending to 0, k divided by epsilon e to the power of j theta. So you are getting k divided by epsilon e to the power of j theta. Now you can take k by e. This you can consider as k by e and k by epsilon into this e to the power of j theta. You can take it to the upper, so it will become e to the power of minus j theta. Okay. Now limit of e tending to 0, k divided by limit of epsilon tending to 0, sorry, limit of epsilon tending to 0, k divided by epsilon. So when epsilon, limit epsilon tending to 0, k divided by epsilon. So here when epsilon tending to 0, some term divided by 0 become infinity, then e to the power of minus j theta. And theta, you try to understand, theta varies from minus pi by 2 to 0 to plus pi by 2. Pi varies from plus pi by 2, 0 and minus pi by 2. So you have to, there are two angles, one is theta and pi. Theta arises only when there is a pole on imaginary axis or at the origin. In that case only this considerations, this eta terms consideration, we have to do it. Otherwise there is no need. But C2 definitely, in all case C2 is there, so that you have to analyze it. So when you are coming to the problem, when you are coming to the problem, you will get a k by eta, so it becomes infinity e to the power of minus j theta. And theta varies from minus theta. Minus theta varies from, here, this is minus theta. So minus theta varies from minus of minus 90, so plus 90, 0, minus of plus 90, that is minus 90. So theta varies from minus 90 to plus 90. Okay, theta varies from minus 90 to plus 90 degree. Thus the infinitesimal semicircular indent around the origin of S plane maps into a semicircular arc of infinite radius in G of S, H of S plane, extending from plus 90 through 0 to minus 90 degree. So there is a, as you can see that in this term there is a minus theta is there. So it will start from infinity. Theta varies from minus 90, minus of minus 90, so it is plus 90, then 0, then plus 90, minus of plus 90 become, so it is from 90 degree to 0 to minus 90 effectively, because it is e to the power of minus theta. So it is having amplitude. So what you will do, you will get the arc with the radius infinity. This will, if you so its representation in Q of S plane will be from plus 90 to minus 90 through 0. It is having infinitesimal infinity radius, okay, a radius of infinity from plus 90 to minus 90 through 0. So you are getting an arc of radius infinity. So this arc is made due to this bypass of pole, and its direction, it is from minus 90 to plus 90. So the arrow will be, so till here we drawn, from there you have to connect it. So from here to infinity. So it is a continuation. So we got an idea from plus 90 to minus 90. There is an arc of radius infinity. We mark the point omega at minus infinity, omega is equal to 0, you got a point. So after that omega is equal to 0 plus, so you have to reach here. So from here to here it is infinity, so you can join that. So like that you will get an arc like this. Now next we have to see what happened is, next is the infinite semicircular arc in the Nyquist contour. This infinite that is mapped into C2 in figure 5, mapped into Q of S plane or Nyquist plot, how it is mapped. So that we have to look in. For that again we have to substitute S is equal to R into e to the power of j pi, where R tending to infinity and pi varying from, here it is plus 90. So direction, you know that the arc is from here to here. So this is plus 90, 0, minus 90. But in this case it is from this direction is like this. So minus 90 is 0, plus 90. This is theta. Here it is pi. So pi varying from, so try to understand, pi varying from plus 90 through 0 to minus 90 is mapped into. So what you have to do, again in your open loop transfer functions, you need to substitute k divided by s, r into e to the power of j pi, 2s, 2 into r into e to the power of j pi plus 1. And here limit of r tending to infinity, So here r tending to infinity means this will become infinity. Infinity plus 1, infinity only. So you can eliminate this as 2r into e to the power of j5 you can take. You have to multiply this with this. So you will get a 2r square. You will get 2r square, limit of r tending to 0, k divided by 2r square e to the power of, here j pi e to the power of j pi into e to the power of j pi is equal to e to the power of 2 pi. So you are getting e to the power of j 2 pi, k divided by 2r square e to the power of j 2 pi. Now this e to the power of j 2 pi, you can take it above. So it will become e to the power of minus j 2 pi. And k divided by r tending to infinity, k 2r square. So it is k divided by infinity. So k divided by infinity. Some term divided by infinity definitely become 0. So effectively it becomes 0 into e to the power of minus j 2 pi. So try to understand how we are doing. This is not very difficult, very easy to understand. Now you got it. 0 into e to the power of minus j 2 pi. Pi varies from plus 90 to minus 90. So you will get it when you are substituting plus 90, 2 into 90, 180 degree with a minus sign. So minus 180 degree. Then when pi is equal to 0, it is become 0. When pi is equal to minus 90, it become plus 180 degree. So it varies from radius, it is having magnitude of 0 from where to where? It is minus 180 degree through 0 to 0 degree. So the effect of this C2 in the Nyquist plot is effect of C2 in Nyquist plot is from minus 180 to 0, it is 0. From 0 to plus 180 degree, again it is 0. So totally it is 0. So that won't come into effect of this because it is 0 from minus 180 degree to 0 to plus 180 degree. Okay. So considering these factors, okay, you have drawn this. Okay, you have drawn this like this. So here basically what you can understand whether it is stable or not. Since there is no zeros on the right half of plane, and in the expression itself there is no zeros. The poles are at the origin as well as left half of S-planes. This open loop system is stable. What about the closed loop system? The given open loop system has no poles in the right half of the S-plane. If right half of S-plane, if there is any pole on the right half of S-plane, then P counts that. But here there is no poles on the right half of S-plane. P is equal to 0. There is no right half of S-plane in the, there is no 0 on the right half of S-plane. So Z also 0. So the number of counterclockwise arc that n is equal to 0 in this case per the Nyquist stability criterion. For the closed loop system to be stable, the Nyquist plot of G, J, omega, H, omega must not encircle the minus 1 plus 0 point. If there is a pole on the right half of S-plane, pole or zeros on the right half of S-plane, then there should be an encirclement in the counterclockwise, encircle around minus 1 J0 in a counterclockwise direction, then the system is stable, provided that there are poles plus zeros on the right half of S-plane. But in this case, there is no 0 at all. 0, there is no 0 at the right half of S plane, so Z is 0. Then there is no pole at the right half of plane, so P is equal to 0. Z is P minus Z. So, yeah, not Z. Yeah, N is equal to P minus Z. P is equal to 0, Z is equal to 0. So, N also 0. N is the resultant encirclement. Here there is no encirclement. So what happened is, so there is not necessary to, if there is a pole on the right hand if a pole on the right half of S plane, then there should be an encirclement in a counterclockwise. Then the system is stable, otherwise it won't be stable. But here there is no pole on the right half of plane. There is no 0. N is 0 here. So there is no need of encirclement in this case, since the actual Nyquist plot in figure 8.b does not encircle the minus 1 plus j0 point. The closed loop system in this case is always stable. Okay, so here, dear student, you should understand that first you check whether there is right hand side zeros. Due to 0, you understand right hand 0. We studied in the first class about this Nyquist criterion. We studied that if there is a right hand 0, there is a counterclockwise contour. No, clockwise contour, minus 2 pi. Okay, minus 2 pi. If there is a right hand side pole, then counterclockwise contour. So now, normally in a system, poles are more than or equal to zeros. Try to understand that. Now, if there is, you have to see the net encirclement. In order to find that, we use an expression N is equal to P minus Z. P is the right hand poles, Z is the right hand 0. P minus Z. Okay, P minus Z. So suppose if there is a 1 right hand pole and 0 right hand 0. So P minus 0 is equal to 1. So N should be